Hi and welcome. You're watching an overview of Solid Edge Finite Element Analysis, Geometry Preparation and Selection. After you've selected a study type, simulation prompts you to select the geometry you wish to include in the study. You don't need to include everything you have modelled if you are only interested in some of the parts. If the geometry exists, just select what you want to study and accept it. If the geometry does not exist yet, or it exists in a form you don't want to use for analysis, you may come back to the geometry definition step at any time after creating the geometry. There are tools in the Simulation Geometry tab to allow geometry to be created or modified in specific ways that will only be used for a simulation. Some examples may be extracting mid-surfaces from sheet metal components, extracting offset surfaces to allow surface modelling of thin-walled parts, splitting surfaces or faces to allow loads, constraints or joints on only select regions, removing faces or features that we don't want to consider for the analysis, and joining solid and or sheet bodies together so that they are meshed as one, which requires less or no connections. You can perform most surfacing operations, like mid-surfacing, offsetting or splitting, either in the part environment or the simulation geometry environment. Defeaturing operations like removing small holes or surfaces can also be done in either the part environment as a simplified part or in the assembly environment to an associative copy of the part. If you do use the simplified part, ensure the part is displayed as simplified before selecting it in the geometry definition, or it will be analysed as non-simplified or designed. Joining different bodies together is best done in the simulation geometry environment. Here we have a lot of flexibility, allowing copying bodies, surface or solid, surface extension, trimming, splitting and stitching for manifold bodies. Finally, there is the union command, which joins the selected bodies together to form a single continuous mesh. This supports joining surfaces and or solids, but the bodies must at least be in contact, and this should be done as late as possible, as unioned bodies are non-editable. If you wish to join a solid to a surface, just be sure to extend the surface slightly into the solid instead of just touching it onto the solid. This avoids the problem where a planar surface will tip over on applied force due to solid element nodes not supporting rotation when connected to surface element nodes. So that's a quick look at Solid Edge simulation geometry, preparation and selection. Thanks for watching.